Good day. This is our last VSEPR diagram for the PowerPoint, looking at 6 electron pairs around the central atom. And it turns out there are 3 different shapes that we have to deal with as we replace bonded atoms to the central atom with lone pairs on the central atom. And then there will be a final slide that just talks about violators of the octet rule. So we start with AX6, and our example is SF6, and it turns out this is called an octahedral shape. So here's our Lewis structure, and only worrying about the sulfur's electrons around it. All these fluorines would have octets. And the way they can get the farthest away from each other is by being an octahedral. And that means we're looking at 90 degrees between adjacent fluorine atoms and the bonded to the central sulfur in this case. And so again, it's a bit like the Earth, where we seem to have a north and south pole, we can call that, and then we have 4 in the equator. And this is a 3D structure. So we can get a smaller or a bigger angle between these than we have in our Lewis structure, where it'd be 60 degrees. This is showing 90 degrees between the adjacent bonds. So we go through this, and if I'm trying to sketch this out, I'm going to go and start by putting an S in the middle. I'll put an F on top. Now, if there was any other halogen, if it's chlorine or bromine, it would look the same. I just have a different symbol for these outside ones. Now, sometimes we really like to show it's 3D. And one way we can do that is we go like that. We go diagonally here, and we go diagonally to there. And then what I do is I make it a little bit short right here in the equator, and a little bit short in the equator. All the bond lengths would be the same, but what I'm trying to show is these guys are sort of sticking towards you, and these are back. And so I shouldn't put this dotted line in, but you'll sometimes see a dotted line put in. You can ignore, don't bother drawing this dotted line, but this is trying to show that it's 3D, and it's hard to do a dotted line with this lovely thing. Anyways, that's trying to show they're in the equator and one up and one down. So all the electrons around the central sulfur are involved in bonds to atoms. And so that's a nice, and it's just reminding us it's 90 degrees between each thing. Now when we go to the next one, we're going to get rid of an atom, and it's going to be replaced with a lone pair. Doesn't matter which one we do, it's going to end up with the same shape. Before we do that, I should let you know why it's called octahedral. The octa means 8. And if we look at this, we would actually be enclosing it with 8 triangles. 4 down below and 4 above. So it took 8 triangles to enclose this shape. That's why it's called octahedral. Okay, and another space-filling model of that. So now we're into our IF5. And again, we're not worried about the fluorine's electrons. They'd all have an octet. But here we have IF5, and we have a lone pair, E, hanging out right here. So if I was drawing this, I'm going to cleverly put an I as my central atom. And then I'm going to, let me backtrack, and I did not like that. Okay, let me get back to this. See if I can do a better drawing. Get out of there. All right. So here I have my I. And then I'm going to have an F straight above it. And then I'm trying to show that these guys, all the other fluorines, are in the equator of its structure. In other words, it's like I've got rid of the south pole of this beastie. It'd be nice to have a decent pen here. And if I try to enclose this shape, the lone pair adds nothing to the shape of this molecule or the size. And so when I can try to enclose this, it is a pyramid, but this time it has a base that is square because of all those atoms. That's why it's called square pyramidal. And that's just another representation of it. Now I have a choice. I'm going to go to AX4E2 and I have to decide, do I put a lone pair here or do I replace this? Now lone pair interactions are the ones we want to get rid of the most. We want the lone pairs to be far enough away because they are held the most tightly to the central atom. Electrons involved in a bond, these atoms are actually pulling those electrons away from the central atom. So if you have a lone pair interactions are going to be the ones we try to minimize the most. And there's our space filled molecule. So we're going to have AX4E2. This will be our last structure that we have to draw. ICl4- is our example. And so here we've ended up with 2 lone pairs left over. All the other pairs of electrons are involved in bonding. It's an ion, so that's why it has the square brackets. So if I'm drawing this structure, I'm going to do something like this. I'm going to put an I like so. And then I'll put a Cl. I'm just trying to make it a little bit 3D. And a Cl like that. And then a Cl in this part of the equator. And a Cl in that part of the equator. What it means, I've got a lone pair up here, a lone pair there, and I've made the lone pairs 180 degrees apart. If I put the lone pair here, my lone pairs would be 90 degrees apart. That goes against VSEPR. VSEPR is all about getting the electrons away from each other. So there, I put square brackets 1-. There are the lone pairs as far apart as possible. And because when we actually do structural diagrams, we don't include lone pairs, it's square planar. This thing will lie flat in a table and be an absolutely flat structure. Here's our last slide, just a few final comments. So if we have molecules at 4 electron pairs around the central atom, they're obeying the octet rule. If they're not, then they're going to be violating the octet rule. You have to remember boron and beryllium. Beryllium only wants 4 electrons, 2 bonds around it, and boron wants 6 electrons, 3 bonds around it. Anything more than 4 electron pairs around the central atom, I would write violator, and I'd have to tell you it's a violator, and I'd have to give you some more clues. So that's what's reminding you what you have to memorize and what you do not have to memorize. So that's it for VSEPR in terms of PowerPoints. You have videos to watch of the shapes for AX6, AX5E, and AX4E2, and that will round out the basic VSEPR notes.